There is a pale band of light that crosses the night sky on a clear evening, stretching from one horizon to the other like a faint smear of dust on dark glass. It does not announce itself. It does not flicker. It simply sits there, the way it has sat there for as long as anyone has looked up. Most people who notice it at all describe it the same way: a haze, a smudge, something that might be cloud, except the stars shine through it. It is not cloud. That band of light is made of stars, so many stars, so far away, that their individual points blur together into something closer to mist. Some of those stars are hundreds of light years distant. Others are tens of thousands. The light reaching your eyes tonight left those stars before you were born, in some cases before your grandparents were born, and it has been traveling ever since, arriving now, in this exact moment, on this exact night. Here is the part that takes a little longer to settle. That band of light is not something you are looking at from the outside. It is something you are inside of. The faint smear overhead is a cross-section of your own galaxy, viewed from a point somewhere within it. You are not observing a distant structure. You are observing your own neighborhood, seen edge-on from the inside. Tonight, we are not going to travel anywhere dramatic. We are going to start exactly where you already are, inside this pale band of light, and slowly widen the view. From this single galaxy, to the handful of galaxies near it, to the much larger gathering those galaxies belong to, and finally, to the structure that holds all of that together. Nothing about this needs to be solved tonight. The band of light will still be there tomorrow, exactly where it has always been. We begin here. For almost the entire span of human history, nobody knew what that pale band actually was. This is worth sitting with for a moment, because it is easy to assume that earlier generations simply lacked detail, that they saw the same picture we see, just blurrier. That is not quite what happened. They were not missing a detail. They were missing the entire frame. The band of light was there every clear night, the same as it is now, and for tens of thousands of years, every person who looked at it was looking at the inside of a structure they had no way of recognizing as a structure at all. Different cultures filled that gap in different ways. Some described the band as a river crossing the sky. Others described it as a road, a path walked by spirits or ancestors, a seam where the ordinary sky had worn thin. In parts of the world, it was treated as something closer to a boundary, the place where one kind of species ended and another began. None of these descriptions were wrong, exactly. They were simply working with the only information available, which was, there is a faint band of light, and it has always been there. A person standing under that sky 1,000 years ago, wrapped against the cold, looking up at the same pale stretch of light you might glance at tonight, was experiencing something genuinely shared across an enormous span of time. The light itself has shifted only slightly in that span. The stars have moved, but slowly, on timescales that make 1,000 years look like nothing. The band looked almost exactly the same to them as it does to you. What was different was not the sky. What was different was the absence of a single piece of information, that the band was not a feature in the sky, but the sky itself, folded into a shape large enough to hold a sun and a planet and the person doing the looking. That piece of information did not arrive quickly, and it did not arrive easily. But for a long time, astronomers were aware of certain faint, fuzzy patches of light scattered among the stars. Not the band itself, but separate smudges, distinct from the pale river overhead. These patches were catalogued, named, argued about. Some thought they were clouds of gas drifting within our own system of stars. Others suspected they might be something else entirely, though nobody could say what that something else would even mean. The disagreement persisted for a long time, in part because the question itself was hard to ask correctly. If someone had suggested, a few centuries ago, that one of those fuzzy patches might be an entire separate collection of stars, its own complete structure, its own immense population, sitting at a distance so great that all of it blurred into a single point of haze, the suggestion would have required reimagining the size of everything, not just the patch, everything. In the early 20th century, That reimagining finally happened. Careful observation showed that at least one of those faint patches was not nearby at all. It was extraordinarily far away, so far that the only explanation was that it contained its own enormous population of stars, comparable to the band of light overhead, just much farther off. The fuzzy patch was not a cloud near us. It was another version of the structure we were standing inside of. The astronomer most associated with settling this question was Edwin Hubble, whose name is now attached to one of the most famous telescopes ever built. But long before that telescope existed, Hubble's work on these faint patches did something quieter, and in its way, more disorienting. It did not just add new objects to the night sky, it changed what the night sky was made of. Before that work, the dominant view among many astronomers was straightforward, and it had been the dominant view for a very long time. The pale band overhead, with its hundreds of billions of stars, was essentially everything. Not literally every single object in existence, but the entire scale of what a galaxy of stars could mean. Beyond it, space continued certainly, but nothing else of comparable size was assumed to exist within it. The band was the unit. There was nothing larger to compare it to. That assumption wasn't careless. It matched everything that had been observed up to that point. The fuzzy patches scattered among the stars were small, faint, and, if they were simply nearby clouds within our own galaxy, as many believed, entirely consistent with a universe where one large structure of stars was the largest thing there was. What changed everything was a measurement of distance, not a guess. Not an estimate based on brightness alone, but a method that allowed astronomers to calculate, with reasonable confidence, how far away one of these patches actually sat, and the number that came back was too large. Far too large for the patch to be inside our galaxy at all. The only way the math worked was if that patch of light was its own galaxy, sitting at a distance so great that an entire population of hundreds of billions of stars blurred into a single faint smudge. Once that single measurement held up, the unit changed. The pale band overhead was no longer the largest thing. It was one example of a kind of thing, and an unknown, possibly enormous, number of other examples existed, scattered across distances that made the band itself look, suddenly, quite small. Once that shift took hold, the pale band overhead stopped being simply the sky and became something else. One structure among an uncountable number of similar structures, each one a separate gathering of stars, each one its own quiet accumulation of light, traveling for thousands or millions of years before reaching anyone at all. And the person standing under that band 1,000 years ago, the one who called it a river, or a road, or a scene in the dark, had not been wrong to notice it. They had simply been looking at something they had no name for yet. In ancient Egypt, in ancient Polynesia, in the cold open spaces of the northern steppe, people lay back and watched the same pale light drift slowly overhead through the night, generation after generation, without ever knowing they were looking at home from the inside. A sailor crossing open ocean 1,000 years ago, navigating by the stars without any instrument beyond memory and practiced attention, would have used that pale band as one part of a much larger picture, a backdrop against which individual stars rose and set in predictable places, night after night, season after season. The band itself wasn't the tool. It was the unchanging stage on which the tools, the individual bright stars, the planets, the slow seasonal drift of everything, performed. Nobody navigating by starlight needed to know what the backdrop was made of. They needed only for it to stay where it was supposed to be, and it always did. That kind of relationship with the sky, useful without being understood, describes most of human history. The pale band was simply present, the way the horizon is present, or the way the ground underfoot is present, not a mystery requiring an answer so much as a fact requiring nothing at all, except perhaps a name, and a story to go with the name. We are going to spend the rest of tonight looking at that same light a little differently. So what is this structure? Exactly, the one we are inside of, the one that produces the pale band overhead. Start with the simplest possible description. It is a vast collection of stars, held together by gravity, all slowly orbiting a shared center. That description is accurate, and it is also almost useless on its own, because the numbers involved stop meaning anything fairly quickly. Our galaxy contains somewhere between 100 billion and 400 billion stars. Astronomers are still narrowing that range, which is itself worth noticing. We live inside this structure, and counting its contents precisely remains difficult, the way counting every tree in a forest remains difficult, even when you are standing in the middle of it. Try this instead. Imagine counting one star every second, not for an hour, not for a day, every second continuously, with no breaks, no sleep, no pauses, for as long as the counting takes. To reach 100 billion this way would take more than 3,000 years, and 100 billion is the low end of the estimate for how many stars our galaxy contains. Now place yourself inside that number. Our Sun, an entirely ordinary star, neither unusually large nor unusually bright, sits roughly halfway between the center of this structure and its outer edge, not at the center, not near the edge. Somewhere in the middle distance, in what might be called an ordinary neighborhood, if a galaxy can be said to have neighborhoods. From here, looking toward the center, there is a dense, glowing core, a region where stars are packed more tightly, older on average, with a warmer, more golden light than the bluer stars found farther out. And at the very center of that core, astronomers have found something that does not behave like a star at all. It is called Sagittarius A star, and it is a black hole, a region where gravity has become so concentrated that nothing, not even light, can escape from within a certain boundary. Its mass is estimated at around 4 million times the mass of our Sun, compressed into a space that, by galactic standards, is almost nothing. Stars near the center of the galaxy can be seen orbiting this object, tracing out paths that bend unmistakably around something massive and completely dark. It is strange to think about, even briefly. Somewhere in the direction of that dense, glowing core, past more stars than could be counted in a human lifetime, there is a single point where the rules quietly change, and everything nearby moves in response to it, the way water in a basin moves in response to a drain. There is something else surrounding all of this, something that doesn't show up in the pinwheel shape at all, above and below the flat disk that contains the spiral arms, outside the part of the galaxy that produces the pale band overhead. There is a much larger, much fainter region, shaped less like a disk and more like a sphere, loosely wrapped around everything else. Scattered through this region are dense, ball-shaped clusters of stars, each one containing anywhere from tens of thousands to a few million stars, packed closely together, all orbiting the galaxy's center on long, looping paths that carry them far above and below the disk, before bringing them back through it again. Our galaxy has more than 100 of these clusters that astronomers have found so far. Many of them are older than almost anything else in the galaxy. Some contain stars that formed not long after the first stars anywhere began to shine, stars that have been quietly orbiting, generation after generation of younger stars forming elsewhere, while these older populations simply continue their long loops through the outer dark. From the ground, a few of these clusters are visible as faint, fuzzy points, easy to mistake for unusually soft stars if you don't know what you're looking for. Each one is, in a sense, its own small society, tens of thousands of stars bound tightly together, traveling as a single unit through a much larger structure that mostly ignores them. But the center is not really where this structure shows itself most clearly. That happens farther out, in the arms. If you could view our galaxy from directly above, a perspective no human being has ever actually had, though we can reconstruct it through careful measurement, it would not look like a uniform disk of light. It would look like a pinwheel. Long, curving arms would spiral outward from the central bulge, each one brighter than the space between them, each one tracing a graceful curve before fading into the darker regions farther out. The obvious explanation for this shape is that the whole structure is spinning, and the spinning has wound the arms into spirals, the way stirring a cup of coffee with cream in it create swirling patterns. For a long time, this seemed like the complete answer. It is not. Here is the problem. If the arms were made of the same stars permanently, locked in place and carried around by rotation, they would not stay as neat spirals for long. Stars closer to the center complete an orbit faster than stars farther out, the way a smaller racetrack takes less time to circle than a larger one, even at similar speeds. Over time, this difference would wind the arms tighter and tighter, like a watch spring being over-tightened, until the spiral pattern collapsed into something closer to a solid, blurred disk. And yet, when astronomers look at galaxy after galaxy across the universe, the spiral arms remain clean, distinct, recognizable, not wound into mush. The resolution turns out to be something closer to a traffic pattern than a physical object. Picture a busy road where, for whatever reason, traffic temporarily slows in one stretch. Perhaps the road narrows slightly, or there's a slight incline. Cars enter that stretch, slow down, and bunch together. Cars ahead speed up again once they're past it. From a distance, looking down at the road, you would see a dense cluster of cars sitting in roughly the same place, even though the actual vehicles inside that cluster are constantly changing. The traffic jam has a location. The cars do not stay in it. Spiral arms behave in a similar way. They are not fixed collections of stars riding around the galaxy together. They are regions where material, gas, dust, and stars temporarily becomes more concentrated, the way cars become concentrated in a slow stretch of road. Stars and gas drift through these regions, slow down slightly due to the increased gravity of the denser material, and then continue on. The arm itself, the pattern, the shape, persists, even as its contents are continually replaced. There is one more feature worth knowing about, one that took a surprisingly long time to confirm, for a reason that's almost funny once you think about it. Near the center of our galaxy, inside that dense glowing core, the stars are not arranged in a simple circular shape. Instead, they stretch out into a long, elongated structure, a bar of stars crossing through the central region before the spiral arms curve away from either end. This kind of feature is common. Many spiral galaxies have one. But for a long time, astronomers genuinely weren't sure whether our own galaxy did. The reason is almost embarrassingly simple. We are inside the galaxy. Determining the overall shape of something from a vantage point buried within it is difficult in the same way it would be difficult to describe the outline of a forest while standing among its trees. You can see what's nearby clearly enough, but the overall shape has to be pieced together indirectly through careful measurement of how things are distributed in different directions. It took improved observations, particularly at wavelengths that can see through the dust that otherwise blocks the view toward the galaxy's center, to finally confirm it. Yes, our galaxy has a bar too, stretching across its central region, just like so many of the spirals we can see clearly from the outside. This means the spiral arms aren't simply attached to a round central bulge. They emerge from the ends of this elongated bar, curving outward from there, a detail invisible from the inside, confirmed only through patient, indirect work, and yet true the entire time. The way most of what's described tonight has been true the entire time, regardless of when anyone got around to confirming it. And this slowing down matters for another reason. When gas drifts into one of these denser regions, it gets compressed. Compressed gas is exactly the condition needed for new stars to form. So the spiral arms are not just visually brighter, they are genuinely more active, genuinely younger, filled with newly formed stars that burn hot, blue, and bright before settling into long and quiet lives. The arms glow partly because they are, in a very real sense, under construction, over and over again, in a slow rolling pattern that has likely been running for billions of years. Meanwhile, the older stars, including many of the ones near the dense central bulge, simply continue their long, quiet orbits, unaffected by which part of the structure currently counts as an arm. They were born long ago, in arms that have since moved on, and they will keep orbiting long after the current arms have shifted into different configurations. There is something worth noticing in this. The pale band of light overhead is not a static picture. It is closer to a long exposure photograph of something that never stops moving. Stars completing orbits that take hundreds of millions of years each, gas drifting into denser regions and lighting up, older populations settling into the slow, steady middle of their long lives. There is a particular kind of stillness in realizing this. As a child, looking up at that same band of light for the first time, not knowing what it was, not even thinking to ask, you were already standing inside all of this. The slow turning, the drifting gas, the ancient core with its quiet dark center. None of it needed to be understood for it to be true. It was simply there, the way it had always been there, the way it still is now. We have been talking about this structure as a single object, our galaxy, the one pale band overhead. But it is not alone. Nothing in the universe, it turns out, really is. Step back far enough from our galaxy, and a strange thing happens. The pinwheel shape, the spiral arms, the bright core, the long graceful curves, starts to look less like the default appearance of a galaxy, and more like one option among many. Some galaxies, when viewed from a distance, show none of that structure at all. No arms, no obvious disk, just a smooth, softly glowing shape, brightest at the center, and fading gradually outward, like a lamp seen through frosted glass. These are called elliptical galaxies, and despite their calm, almost featureless appearance, some of them are the largest individual structures of stars known to exist anywhere. Consider one example, found within a large gathering of galaxies in the direction of the constellation Virgo. This galaxy contains not billions of stars, but trillions, an amount large enough that billions stops being the right unit. Its light fades smoothly outward in every direction, with no spiral pattern to interrupt it, no dust lanes cutting across its surface. At its center sits another black hole, but on a completely different scale than the one at the heart of our own galaxy. This one with a mass measured in billions of suns, not millions. In recent years, this particular black hole became the first one ever to be captured in a direct image, a faint ring of light surrounding a dark center, assembled from data collected by telescopes, spread across the entire planet, all working together as if they were one enormous instrument. Why would a galaxy end up looking like this, smooth, rounded, without arms? The leading explanation involves collisions, not collisions in the way two cars collide, but something slower and stranger. Two large spiral galaxies, each with their own arms and disks, gradually drawn toward each other by gravity over hundreds of millions of years. As they approach, their shapes begin to distort. Gas clouds within each galaxy crash into gas clouds from the other. Orbits that were once neat and orderly become scrambled, stars moving in increasingly random directions rather than following smooth, shared paths. Eventually, the two structures merge into one, and the orderly disk and arm pattern that depended on coordinated motion simply stops existing. What remains is a smooth, rounded cloud of stars moving in many directions at once, an elliptical galaxy built from the wreckage of two spirals that no longer exist as separate things. If that explanation is correct, then somewhere in the deep past, the enormous elliptical galaxy near Virgo was not one galaxy, but several, each with its own arms, its own quiet stretches of star formation, its own slow turning. All of that history is still present, in a sense, woven into the orbits of its stars. It simply no longer looks like history. It looks like calm. Not every galaxy fits neatly into spiral or elliptical, though. Some occupy a strange middle ground, a flattened, disc-like shape similar to a spiral galaxy, but without any of the spiral arms. One well-known example, sometimes called the Spindle Galaxy for its narrow, elongated appearance, shows a bright central bulge and a thin surrounding disk cut across by dark bands of dust. Seen edge-on, it resembles a spiral galaxy at first glance. Look for the arms, though, and they simply aren't there. One way to understand this kind of galaxy is to think about what spiral arms actually need in order to exist: fresh gas, ongoing star formation, a steady supply of young, bright stars to light up the denser regions. If a galaxy gradually loses that gas, through age, through gentle interactions with its surroundings, through slowly drifting through regions where gas gets stripped away. The arms don't collapse dramatically. They simply fade as the young blue stars that made them visible burn out and are not replaced. What remains is the underlying disk shape, now populated mostly by older, redder stars, with no new construction lighting up any particular region. The structure is the same. The activity is gone. In some ways, this kind of galaxy is a portrait of a particular moment, not the beginning of a spiral's life, and not the smooth, scrambled aftermath of a major collision, but something in between, a structure that still remembers what it used to look like, even as the details that made it recognizable slowly disappear. Then, there are galaxies that seem to have given up on tidy shapes altogether. Visible from the southern hemisphere without any telescope at all is a galaxy that looks, to the naked eye, like a faint, detached patch of the Milky Way, a smaller cloud of light sitting near the main band, but clearly separate from it. For a very long time, people simply saw it as part of the sky, a permanent fixture, without any sense that it represented a separate structure of stars in its own right, orbiting our galaxy at a distance of roughly 160,000 light-years. Up close, this galaxy has no spiral arms, no smooth elliptical glow, just an irregular scattering of bright regions and dark gas, with one area in particular standing out as extraordinarily active. Within it sits one of the most energetic star-forming regions known anywhere nearby, a vast cloud of gas where massive new stars are being born in unusually large numbers, glowing with a brightness that, if it were as close as some familiar star-forming regions, would be visible across enormous distances, far outshining anything else in the night sky. A smaller companion galaxy sits nearby, similarly irregular, similarly without any obvious symmetry, its shape stretched and distorted by billions of years of gravitational tugging, both from our galaxy and from its larger neighbor. Together, these two companions form a quiet, lopsided little system orbiting slowly, their irregular shapes a direct record of every gravitational nudge they've experienced. It is worth noticing that irregular does not mean unimportant or even rare. Some of the earliest galaxies that formed billions of years ago may have looked something like this, chaotic, clumpy, still in the process of figuring out what shape they would eventually settle into. In that sense, these small, irregular companions might be carrying echoes of what galaxies looked like when the universe itself was much younger, and size, it turns out, has very little to do with importance. Surrounding our galaxy, and likely surrounding most large galaxies throughout the universe, are smaller companions, sometimes containing only a few million stars, sometimes only a few thousand. These are called dwarf galaxies, and despite the name, they may be the most common type of galaxy that exists, not the giant ellipticals, not the graceful spirals, the small, faint, easily overlooked companions. One of these companions has had a particularly difficult relationship with our galaxy. It orbits close enough that our galaxy's gravity has been slowly pulling it apart for a very long time, stretching long streams of its stars out into space. Streams that stretch across a significant portion of the sky if you know where to look. Eventually, this companion will likely stop existing as a separate structure altogether. Its stars will simply become part of our galaxy, absorbed gradually, the way a smaller stream might be absorbed into a larger river without ever announcing the moment it happened. Another, smaller companion orbits much farther out and has revealed something stranger. When astronomers measured how its stars were moving, the motion didn't match what the visible stars alone could explain. There was clearly more mass present than could be accounted for by anything that gave off light. Far more. In this particular dwarf galaxy, the visible stars appear to represent only a small fraction of its total mass. The rest is something astronomers call dark matter, present, gravitationally significant, and completely invisible. This is not unique to small galaxies. Dark matter appears to be woven through galaxies of every size, including our own. But in a small, simple galaxy with relatively few stars, its presence becomes much easier to detect. The way a quiet room makes it easier to notice a single sound that would be lost in a crowd. There is something almost generational about these small companion galaxies, each one a separate population of stars, born at different times, under different conditions, slowly pulled into orbit around something larger, some destined to be absorbed entirely, others destined to keep orbiting for a very long time, quietly carrying their own histories alongside the much larger structure they travel with. One more of these companions is worth knowing about, because its history turns out to be more complicated than its small size would suggest. Orbiting at a distance of roughly 460,000 light-years, this dwarf galaxy contains several dense star clusters of its own, smaller versions of the ball-shaped clusters we encountered earlier. Orbiting within an already small galaxy, clusters within a companion, and when astronomers examined the ages of its stars, they found not one population, but several. Some extremely old, some considerably younger, formed long after the galaxy's earliest stars had already lived out their lives. That detail matters more than it might seem to. A small galaxy isn't necessarily a simple galaxy. Even something this modest in size can carry a long, layered history. Multiple generations of star formation separated by enormous stretches of time, all happening within a structure that, from the outside, might look like nothing more than a faint smudge easily mistaken for a distant, unremarkable star cluster. Smallness, in other words, doesn't mean simplicity. It just means there's less material to read the history from, which, if anything, makes the history that is there a little more precious, the way a short letter can sometimes carry as much as a long one, simply written more carefully. Beyond the smooth ellipticals, the fading lenticulars, and the irregular dwarfs, there are a handful of galaxies that look almost too strange to be real. One of these resembles a wheel, a bright, glowing ring of light surrounding a much darker central region, the whole structure looking, from a distance, like something deliberately designed. It sits roughly 500 million light-years away, and its shape is the result of something rare. A smaller galaxy passing directly through the middle of a larger one, sending a wave of compression rippling outward through the larger galaxy's disk, the way a stone dropped into still water sends ripples outward from the point of impact. As that wave moved outward, it compressed gas ahead of it, triggering intense star formation in a ring-shaped pattern, a wave of new stars, frozen in place, marking the path of an event that happened hundreds of millions of years ago and will likely never happen again to that particular galaxy. Another galaxy, even stranger, shows an almost perfectly circular ring of young blue stars surrounding a separate, glowing yellow core with a gap of empty space between them, so symmetrical that it looks almost artificial. Even now, there isn't full agreement on exactly how it formed. Sometimes the universe produces something that simply resists a tidy explanation. And in a few places, astronomers can watch this kind of transformation happening right now, mid-collision. Two galaxies, not yet merged, caught in the act of passing through each other, long streams of stars and gas stretching out behind each one like trailing ribbons, each galaxy's shape visibly distorted by the other's gravity. Neither galaxy remains what it was. Neither has yet become whatever it will eventually be. They exist, for now, in the middle of a transformation that will take hundreds of millions of years to complete. A transformation that, from far enough away, might one day be mistaken for a smooth elliptical glow, with no obvious sign that it was ever two galaxies at all. There is one more kind of galaxy worth knowing about, and it tends to show up exactly where you'd expect, given everything we've just covered, in the aftermath of an encounter. Most galaxies form new stars at a slow, steady pace. A few clouds of gas collapse here, a few there, spread out across enormous stretches of time. But occasionally, usually after a close pass with another galaxy, something different happens. Gas that was once spread thinly throughout a galaxy's disk gets compressed, suddenly and substantially, into much denser regions. And dense gas, given enough time, becomes new stars, not a few, but enormous numbers of them, appearing within a relatively short span. Astronomers call this a starburst, and the name is fitting in its plainness. One well-studied example sits roughly 12 million light-years away, a galaxy with an elongated, slightly disturbed shape, clearly influenced by a larger neighboring spiral nearby. Across multiple wavelengths, the galaxy shows enormous plumes of gas extending above and below its disk, driven outward by the combined effect of many young, massive stars and the stellar explosions that follow when those stations, having burned through their fuel quickly, reach the ends of their unusually short lives. A starburst does not last. It cannot. There is only so much gas available, and forming stars at that pace uses it up quickly, at least by galactic standards. Within a relatively short stretch of cosmic time, the burst subsides, the galaxy settles, and star formation returns to something closer to its usual quiet pace. What remains afterward is a population of young stars, born all at once, slowly dispersing into the wider disk, eventually becoming indistinguishable from stars that formed the ordinary way. There is one further variation, quieter than a starburst, but in its own way, stranger. At the center of most large galaxies, including, very likely, every elliptical and spiral we've discussed tonight, sits a black hole, the way Sagittarius A star sits at the center of ours. Most of the time, these central black holes are relatively undisturbed, simply present, exerting their gravity on nearby stars, without doing much else. But occasionally, when enough gas and dust fall toward one of these central black holes, it begins to glow. Not the black hole itself, which remains dark by definition, but the swirling material spiraling toward it, heated by the fall to enormous temperatures, radiating outward with a brightness that can, in some cases, outshine every star in the galaxy combined. Galaxies in this state are sometimes called active galaxies, and the giant elliptical near Virgo that we encountered earlier, the one with the photographed black hole, is one of the most famous examples. Beyond its smooth, rounded glow, a narrow beam of energetic material extends outward from its center, visible across an enormous distance, a thin, bright line against the dark, evidence of a central engine quietly doing something that dwarfs everything else happening in the galaxy around it. These active phases, like starbursts, do not last forever either. Fuel runs low, the glow fades, the galaxy returns to something quieter. What remains is simply a galaxy, smooth, or spiraled or irregular, depending on its history, with a calm, dark center, the way most galaxies, including ours, appear most of the time. Every shape we've just walked through, the smooth ellipticals, the faded lenticulars, the irregular dwarfs, the rare rings, the galaxy's mid-collision, the brief bursts of new star formation, the occasional bright glow from a busy center, represents a different point in a very long story. Not separate categories so much as different chapters, different ages, different histories, all happening at once, scattered across the sky in every direction, and every one of these galaxies, ours included, belongs to something larger still. Our galaxy does not travel through space alone, within a region roughly 10 million light-years across, a distance that sounds enormous, and on the scales we're about to reach, genuinely isn't. There are more than 50 known galaxies, all loosely bound together by gravity, all drifting through the same general volume of space. Most of them are small, faint dwarfs, easily overlooked, the kind of galaxies that don't make it onto posters or documentaries. But two large galaxies dominate this gathering, our own and a second spiral galaxy, larger than ours, sitting roughly 2.5 million light-years away. A third, somewhat smaller spiral sits nearby as well, a quieter, less prominent member, easy to miss in photographs that emphasize its two larger neighbors, though it has been forming new stars steadily for a very long time, with no particular hurry about any of it. Together, these three large galaxies, and the swarm of smaller companions orbiting around them, form what astronomers simply call the local group. 10 million light-years sounds like a lot, until you place it next to what comes next. The local group is not isolated either. It sits within the gravitational influence of something much larger, an enormous gathering of galaxies in the direction of the constellation Virgo, roughly 55 million light-years away, containing well over 1,000 galaxies, by some count several thousand. This is the Virgo Cluster, and it includes the enormous elliptical galaxy we encountered earlier, the one with trillions of stars, the one whose black hole became the first ever photographed. Here is the part that's easy to miss. The local group is not simply sitting near the Virgo Cluster as a neighbor, it is being pulled toward it. Slowly, and on timescales that make a human lifetime meaningless, our entire local group, our galaxy, its larger spiral neighbor, every small companion orbiting either of them, is drifting in the direction of Virgo, responding to its gravity the way a small boat responds to a current it cannot see. It is worth pausing on that for a moment. We are not just inside a galaxy, inside a small group of galaxies. We are inside a small group of galaxies that is itself in motion, pulled by something larger. The way a leaf caught in a stream moves not because it chose to, but because of what the water around it is doing. And the local group itself is not the only such gathering nearby. Scattered around it, at distances of a few million to a few tens of millions of light years, are other small groups, smaller collections of galaxies, each centered on one or two larger members, each drifting through space the same way ours does. None of them are far enough away to be considered truly distant on the scales we're about to reach. They are simply other neighborhoods, other small clusters of galactic company, each one going about its own slow business, each one eventually folding into the same larger flow that is carrying our own local group toward Virgo. It is a bit like discovering, after getting to know your own street, that the next several streets over each have their own quiet communities too. Not strangers, exactly, just neighborhoods that haven't had much reason to interact yet, all of them part of the same town, all of them subject to the same roads, eventually leading to the same larger places. How do we even know something that large is pulling on something we're part of? The answer to that question turns out to be one of the more surprising stories in this whole structure. And it starts with a problem that, for a long time, nobody could explain. In the 1930s, an astronomer studying a different, much larger cluster of galaxies, a dense gathering called the Coma Cluster, noticed something that didn't add up. He measured how fast the individual galaxies within the cluster were moving, and the numbers were strange. They were moving so quickly that, based on the visible mass of the cluster, all of its stars, all of its gas, everything that could be seen and measured directly, the cluster shouldn't have been able to hold itself together at all. The galaxies should have been flying apart, scattering in every direction, the way a poorly tied bundle comes apart when you pick it up too quickly. But the cluster wasn't flying apart. It looked stable. It looked like it had looked stable for a very long time. The only way to reconcile these two facts, galaxies moving too fast to stay bound, and a cluster that clearly remained bound, was to conclude that there was more mass present than anyone could see. A great deal more. Mass that didn't shine, didn't glow, didn't interact with light in any of the ways ordinary matter does, but that was still there, still exerting gravity, still holding everything together. This invisible mass became known as dark matter, and for decades it remained a strange, somewhat abstract idea, present in the math, absent from any direct image. Then, much more recently, astronomers found something close to direct evidence. Two enormous clusters of galaxies, each containing its own hot gas and its own dark matter, collided with each other, not quickly, but over a process lasting hundreds of millions of years. As they passed through one another, something interesting happened. The hot gas in each cluster, which makes up most of the visible, glowing material, interacted with the gas from the other cluster, slowing down like two crowds of people pushing through each other and getting tangled in the middle. But the dark matter in each cluster didn't interact that way. It passed through, mostly undisturbed, continuing onward with the rest of each cluster's galaxies. The result was a collision where the visible matter ended up in one place, and the invisible mass, detected only through its gravitational effect on light passing nearby, ended up somewhere else entirely, separated from the gas that should have been traveling with it. For the first time, there was a picture, an actual image, showing visible matter in one location and gravitational mass in another, clearly apart from each other. It remains one of the clearest pieces of evidence that whatever dark matter is, it is real, and it is woven through every one of these structures, from the smallest dwarf galaxies to the largest clusters. Right now, while you are lying here, the light leaving that distant double cluster, light that has been traveling for longer than recorded human history, is still in transit, still crossing the gap between that collision and every telescope currently pointed toward it. It will keep arriving tonight and every night, whether or not anyone is awake to receive it. So, a galaxy, inside a small group of galaxies, inside the gravitational reach of a much larger cluster, all of it threaded through with an invisible mass that outweighs everything we can actually see. It does not stop there. Step back again, far enough that the Virgo cluster itself becomes just one feature among many, and another structure comes into view. An enormous region, roughly 500 million light-years across, containing something on the order of 100,000 galaxies. Our local group sits within it, occupying what amounts to a small corner. The Virgo cluster sits within it too, one of many dense gatherings scattered throughout its volume. This structure has a name that comes from Hawaiian Laniakea, which translates roughly to immense heaven. It was identified by mapping not just where galaxies are, but which direction they're moving. Tracing the flow of galaxies, the way you might trace the flow of water by watching which way leaves drift rather than just where they happen to be at any one moment. When astronomers did this, a boundary emerged, a region within which everything seems to be flowing toward a common, very distant gravitational center, and beyond which galaxies begin flowing somewhere else instead. Within that boundary, 100,000 galaxies. Our galaxy is one of them. Our local group is a small piece of it. The Virgo cluster, with its thousands of galaxies and its giant elliptical with the photographed black hole, is itself just one part of a much larger flow. Water within water, current within current, all of it moving together across distances that make the 10 million light-year span of the local group look almost local, almost local. That word starts to feel strange the further out you go. And yet, at every one of these scales, the galaxy, the group, the cluster, the supercluster, the same basic ingredient keeps showing up: gravity. Patient, invisible in its full extent, working the same way at every size, from a single star orbiting a galaxy's center to 100,000 galaxies, drifting together across 500 million light-years. We are part of all of it, not symbolically, physically. The same gravity that holds the pale band of light overhead together is the same gravity, at a much larger scale, that is currently carrying that entire band of light and everything in it towards something else, somewhere out there, slowly, the way it has been for longer than anything alive has existed to notice. There is a new instrument, recently brought online in the mountains of Chile, built specifically to map structures like these in far greater detail than has ever been possible before. Rather than studying one galaxy at a time, it photographs enormous stretches of sky repeatedly, night after night, building up a picture of how galaxies are distributed and how they move across vast volumes of space. Among its goals is tracing the fainter edges of structures like the local group and Laniakea more precisely than ever, filling in regions that have so far remained dim and uncertain. It will take years for that picture to fully develop. For now, the boundaries of these structures remain somewhat soft at the edges, known well enough to describe, not yet known well enough to map completely. That, too, is part of this story. Even the largest structures we can name are still, in places, simply unfinished maps, waiting for more light to arrive and be counted. If you keep stepping back, past the local group, past the Virgo cluster, past Laniakea and its 100,000 galaxies, something strange begins to happen to the picture. At a certain point, galaxies stop looking scattered. They stop looking randomly placed, the way stars seem randomly placed on the inside of that pale band overhead. Instead, they begin to trace out shapes, long strands, Sheets, connections stretching between dense regions, with vast, mostly empty spaces in between. The universe, at the largest scales anyone has ever mapped, looks less like a scattering of dots and more like a structure. Something with a recognizable architecture, built slowly, over billions of years, by gravity acting on matter that was almost, but not quite, perfectly evenly spread out at the very beginning. Astronomers call this the cosmic web, and the name fits better than most scientific names tend to. Galaxies cluster along filaments, long, thread-like concentrations stretching across enormous distances. Where filaments cross, dense clusters form, the kind of gathering Virgo represents. And between the filaments lie enormous regions containing very few galaxies at all, cosmic voids, vast stretches of space that are not empty, exactly, but are dramatically emptier than the structures around them. Mapping any of this took a very long time, and it required a particular kind of patience. To trace a filament, or outline a void, astronomers needed to measure not just the position of a galaxy in the sky, but its distance, and distance, on these scales, has to be worked out indirectly, galaxy by galaxy, using the faint stretching of its light that comes from the universe's slow overall expansion. Large surveys, carried out over years, measured this stretching for hundreds of thousands of galaxies, one at a time, gradually filling in a three-dimensional picture of where everything actually sits, rather than just where it appears to sit when flattened onto the dome of the night sky. What emerged from all that patient measuring was the web, not assumed, not guessed at, measured, point by point, galaxy by galaxy, until the pattern became impossible to miss. Some of these structures are difficult to describe, without the numbers starting to lose meaning entirely. One enormous filament of galaxies, mapped through large surveys of the sky, stretches across more than 1 billion light-years. A single connected structure of galaxies so long that light itself needs over 1 billion years just to travel from one end to the other. Another, even larger structure identified more recently may stretch across several billion light-years, a significant fraction of the size of the observable universe itself. At scales like this, even the supercluster containing our galaxy, that 100,000 galaxy structure called Laniakea, becomes a relatively modest feature, one thread among many in something far larger. And the voids are just as real as the filaments. One well-studied region of space, hundreds of millions of light-years across, contains remarkably few galaxies compared to its surroundings. A vast, quiet stretch where the galaxy-rich filaments simply don't reach. If the dense filaments are something like cities and highways, this kind of region is closer to open countryside on a scale that swallows entire countries whole. It is worth saying clearly, nobody designed this. There is no blueprint, no plan, no architect. The entire pattern, filaments, clusters, voids, all of it, traces back to extremely small differences in how matter was distributed in the very early universe. Differences so slight that, at the time, they would have been almost impossible to detect. Gravity took those tiny differences and patiently amplified them, over and over, for billions of years, until they became the largest structures that exist. Somewhere within all of this, a small galaxy in a small group, on the inner edge of one filament among many, is the pale band of light overhead. There is one more piece of this story worth knowing, because it concerns where that pale band is headed. The larger spiral galaxy in our local group, the one sitting roughly 2.5 million light-years away, is, by most estimates, even larger than ours. Some counts suggest it may contain close to 1 trillion stars, several times the number in our own galaxy, though both numbers remain difficult to pin down precisely for the same reason our own count is difficult. Counting stars across a structure that size, from any distance, is simply hard. It is also not staying at that distance. It is moving closer, slowly, the way almost everything in this story moves slowly but unmistakably. Measurements of its motion suggest several billion years from now it will arrive. Not as a sudden impact, but as a long gradual passage, two galaxies drifting through each other over hundreds of millions of years, their shapes slowly distorting, their gas clouds mixing, They're populations of stars beginning to share the same space for the first time. It is easy to imagine this as something violent, because the word that gets used most often is collision, and collisions, in ordinary experience, are sudden and destructive. This is not that. Galaxies are, on the scale of their contents, almost entirely empty space. The stars within each galaxy are separated by such enormous distances that, even as the two galaxies pass through each other, individual stars are extremely unlikely to actually strike one another. What changes is the overall shape. Orbits shift, structures stretch. The tidy spiral patterns each galaxy currently has will likely become something else over time, as the two systems settle into a single, larger structure. Whatever that future structure looks like, it will likely resemble, eventually, one of the smooth, rounded shapes we encountered earlier. Not because anything was destroyed, but because two organized systems, once merged, tend to lose the coordinated motion that made their spiral patterns possible in the first place. This will not happen quickly by any measure that matters to a person. It will not happen within a human lifetime, or 1,000 lifetimes, or anything close. The time scale involved is measured in billions of years, long enough that the sun itself will have changed considerably by the time it's underway, long enough that whatever is alive to witness it, if anything is, will be looking at a night sky that has been slowly changing for longer than any species has existed to notice. For now, none of that has begun. The pale band of light overhead looks tonight the way it has looked for as long as anyone has been looking up. The same shape, the same faint stretch across the dark, the same quiet presence it has always had. The galaxy heading toward it is still 2.5 million light years away. The light from that galaxy, arriving at your eyes tonight if you were to look for it, left there 2.5 million years ago, long before there were cities, before there was writing, before there was anyone to wonder what it was. It is still on its way. It will keep arriving for a very long time yet. There is a particular feeling that comes from holding all of this at once, even briefly. Not understanding it. Nobody understands all of it, not fully, not even the people who study it for a living. Just holding it, letting the shape of it sit there for a moment. A star, inside a galaxy, inside a small group of galaxies, inside the gravitational reach of a cluster, inside a supercluster that is itself one strand within a web stretching across the observable universe. Each layer fits inside the next, the way a smaller container fits inside a larger one, except none of the containers have edges you could touch, and none of them were placed there by anything that intended to place them. It might seem like this realization should feel small, that learning you are a tiny part of something almost incomprehensibly large should produce a kind of diminishment. In practice, it doesn't quite work that way, or at least, it doesn't have to. Perhaps it is closer to this. Every one of those layers is also, in its own way, a kind of company. The pale band overhead is not a lonely structure drifting through emptiness. It has companions, small ones, large ones, some being slowly pulled apart, some quietly orbiting for a very long time yet. The group it belongs to is itself part of a larger gathering, which is part of something larger still. At no point, at any scale, is there true isolation. Everything is embedded in something. Everything has neighbors, even if those neighbors are millions of light years away and have never been seen directly by anyone. There is a strange comfort in the idea of layers that don't need anyone to count them. The galaxy does not require an observer in order to have a shape. The cluster does not require a name in order to hold itself together. The web does not require a map in order to stretch the way it stretches. All of it was true before tonight, and all of it will remain true after tonight. Regardless of who is awake to think about it, or for how long, there is an old kind of trust that fits surprisingly well here. The kind sailors once placed in a single steady star, somewhere out over open water, long before anyone understood what that star actually was. They didn't know its size, or its distance, or what kind of object it truly represented. They knew only that it held its position, night after night, crossing the sky the same way it always had, and that this steadiness could be relied upon when almost nothing else could be. The star didn't know it was being relied upon. It simply continued doing what it had always done, and that continuation was enough. In a way, every layer of this, the galaxy, the group, the cluster, the web, has been doing something similar for a very long time, without any awareness that it was doing anything at all. The structure holds together, the gravity continues, the slow drift toward Virgo continues, the larger spiral continues its long approach. None of it requires attention or maintenance or anyone noticing. It simply continues the way the steady star continued for the sailors who trusted it, the way the pale band overhead has continued for everyone who has ever looked up and wondered, even briefly, what it was. Maybe that is part of what makes it possible to rest inside something this large, rather than feel lost within it. Nothing here is waiting for you to figure it out. Nothing here depends on being understood in order to keep going. The galaxy will keep turning, whether or not anyone traces the shape of its arms. The cluster will keep drawing its neighbors inward, whether or not anyone maps the flow. The web will keep stretching across its filaments and voids whether or not anyone ever draws a picture of it. There is something quietly restful in that. Not because it doesn't matter. It matters enormously to the people who spend their lives trying to understand it. But because, on a given night, lying still, none of that effort needs to happen. The structure is already complete enough to hold itself together. It was complete enough before anyone asked a single question about it, and it will remain complete enough long after every question currently being asked has been answered, replaced, or simply set aside for the night. Somewhere above, the pale band continues its slow turn. Somewhere within it, a smaller galaxy drifts steadily closer, exactly as it has for millions of years. Somewhere beyond all of it, filaments and voids hold their shapes across distances that don't need to be measured again tonight. It is, in its own way, a very old kind of steadiness. The same steadiness a sailor once leaned on, without needing to know anything more about the star than that it would be there. It is there now too. Go back to where we started. A pale band of light, crossing the sky on a clear night, stretching from one horizon to the other, a faint smear, easy to mistake for cloud, except the stars shine through it. It looks the same as it did at the beginning of tonight. It looks the same as it did before any of this, the same as it looked to someone standing under it 1,000 years ago, wrapped against the cold, calling it a river or a road or a seam in the dark. Nothing about its appearance has changed. The light reaching your eyes tonight is still just light, faint, steady, arriving the way it always arrives. What has changed, maybe, is what sits underneath the looking. That person, 1,000 years ago, was standing inside this same structure, looking at it from the inside, with no way of knowing that's what they were doing. They saw a band of light and gave it a story because a story was the only kind of explanation available. The story wasn't wrong, exactly. It was simply built from the only material they had, the appearance, the steadiness, the fact that it returned every clear night without fail. You have more material now. Not all of it. Nobody has all of it, but enough to know that the band overhead is not a separate thing in the sky. It is the sky, or at least this part of it, seen from inside. Enough to know that it contains more stars than could be counted in a lifetime, arranged into long spiral arms that are less like fixed structures and more like slow-moving patterns, with a dark, quiet center where gravity behaves in ways that are still strange even to the people who study it most closely. Enough to know that this structure has companions, smaller ones nearby, a larger one approaching slowly from a few million light years away, and that all of those companions together are part of something larger still, drawn gradually toward a distant gathering of thousands of galaxies, which is itself part of something larger, again stretching outward into filaments and voids that span a meaningful fraction of everything that can be observed. None of that changes what's overhead right now. The band of light is exactly what it has always been. It will look the same tomorrow night, and the night after that, and for longer than makes sense to think about. There is a strange kind of company in that thought too. Everyone who has ever looked up at this band of light, the sailor crossing open water, the scribe on a rooftop, the child noticing it for the first time without asking what it was looking at something that contained, somewhere within it, everyone else who had ever looked at it, and everyone who ever would. Not as a poetic flourish, just as a fact of geography. There has never been anywhere else to stand. But there is a difference between looking at something and knowing, even loosely, what you're looking at. Not a difference in the light itself. The light doesn't care whether it's understood. The difference is closer to the feeling of recognizing a place. The same street can look completely different once you know that someone you love once lived there, even though not a single stone has moved. The pale band overhead has always been a kind of home, not metaphorically, but literally, in the most basic sense of the word. It is the structure that contains the sun, which contains the planet, which contains everything that has ever happened to anyone. Every person who has ever lived, every place that has ever existed, every quiet night spent looking upward without quite knowing why. All of it took place inside that band of light, somewhere along one of its slowly turning arms. The person from 1,000 years ago didn't know that. They simply looked up, saw something steady and familiar, and felt, perhaps, a small sense of comfort in its presence. The same comfort that comes from any steady, familiar thing returning night after night, whether or not its nature is understood. That comfort doesn't require understanding. It never did. It was there before any of tonight's explanations, and it will still be there if every one of those explanations is eventually replaced by something else, the way explanations tend to be over time. The band of light is still there, still faint, still steady, still crossing the sky the way it always has, carrying everything. The slow-turning arms, the quiet dark center, the small companions, the larger one drifting closer, the whole structure embedded in something larger than itself. All of it, all at once, the way it has been for longer than there has been anyone to notice. Look up if you're somewhere you can, or don't, it will be there either way. It always has been. The band of light fades a little as the night goes on, not because it is going anywhere, only because the sky around it shifts, slowly, the way it always does, carrying the pale stretch of stars toward the horizon at the same unhurried pace it has followed for longer than anyone has been watching. Somewhere along one of its arms, a single star burns quietly, the way it has for a very long time. Somewhere beyond it, a smaller galaxy drifts a little closer than it was the night before. Not enough to notice, not enough to matter tonight. Somewhere beyond that, filaments hold their shape across distances too large to picture, and voids sit quiet between them, the way they have for billions of years. None of it is waiting for anything. The stars continue their slow arcs. The dark center holds its place. The whole structure turns, the way it turns, carrying everything within it, including this moment, including this thought, including whatever is left of tonight. The band of light is still there. It is fading now, only because morning is coming, the way it always does, the way it always has. The sky holds still,